So yesterday, one of you guys texted me and said, Doctor, can you explain again how to convert, saya baca balik, tak ingat dah. How to convert meter cube to centimeter cube. Okay, let's do it. Okay, we are going to do recap every time I start class, so why not? So meter cube to centimeter cube. Siapa yang didn't get it last time, please pay attention. So if I have like 97376 meter cube and I want to convert it into centimeter cube, so how do I do that? So as I mentioned to you before, I like this approach, which is cancelling out the units. So I have 3 meters squared here. So I want to get rid of meter, right? I want to get rid of meter. So 1 meter is equal to 100 centimeter. We know this. Ini memang kena hafal. So any prefix. Okay. This conversion is not given because centi is a prefix. Both are in base tier meter. So centi ni prefix. So you have to know what is centi. So 1 meter is 100 centimeter. So I want to get rid of meter, right? So meter should be down here. Okay, meter should be down there. And 1 meter is equal to 100 centimeter. Okay, so that is my first step. But we have 3 meters over here. If I cancel this out, I'm left with meter square. Ada 2 lagi meter. So I have to do this 3 times. Okay, 3 times. Okay, when I do this 3 times, then only when I cancel out 1, 2, 3, the 3 m's cancel out and I am left with 1, 2, 3, and this becomes centimeter cube. Okay, and the final unit becomes centimeter cube, and this guy times this guy times this guy times this guy becomes, but okay, so 976 times, we have 1, 2, 3, 4, 5, 6, right? 6 zeros, so 10 to the 6. Okay, so 976 meter cube is actually 976 times 10 to the 6 centimeter cube, or you can write it 976 111 sorry 0.00000 centimeter cube. Boleh, same thing. Okay, so I hope that's clear. Any other questions regarding this? Okay, is everyone okay? Hari ni tak chatty, everyone is not chatty sebab mengantuk lagi agaknya. Okay, any other questions? Clear, okay, good. So let's go on to our actual recap. A new slide. So what have we learned yesterday? Yesterday was our first day of class, belajar betul-betul instead of introduction. So we talked about base quantities, right? Base quantities which could not be broken down, such as length, time, electric current, ampere, and then luminosity, candela, and stuff like that. And then we had derived quantities, okay, which is speed, what else? I can only remember speed right now. Okay, so it's basically made up of 2 or more base quantities. And then density is volume. Density is mass over volume. So that's also a bunch of base quantities in the equation. So that is your derived quantity. So these two are like the pair. And then we talked about scientific notation. Okay, please know how to do this scientific notation. Saya takkan go over again how to do it. If you struggle with scientific notation, please try to revise and try to make yourself comfortable with scientific notation. And for physics, I recommend at least 3 significant figures, 2 decimal places. You call it DC, right? 2 decimal DC? 2 decimal first, sorry. 2 decimal points, DP lah. Okay, so 3 significant figures and 2 decimal points. And then we talked about vectors. Did I miss anything before that? Vectors and scalars. Vectors and scalars. Okay, so I'm going to ask you, what is the difference between vector and scalar? Please tell me. What is the difference?
Direction.
Apa yang direction?
Vector with direction.
So vector, direction. Okay, so that's the difference between them too. What is the common thing between them?
Has
How are they
magnitude.
common? Apa dia? Lagi sekali?
Both has magnitude.
Huh? Tak dengar, sorry.
Has magnitude.
Okay, ada magnitude. Yes, correct. So vectors have magnitude and direction. Scalar has magnitude. So quantities such as Newton, so quantities such as forces, which is in Newton, velocity, semua ni ada direction. They all have direction. And scalar such as length. If I tell you about length, you wouldn't know whether it's going to the right, to the left, or down, right? So that is scalar. Yeah. Saya cuba mute. Sebab saya rasa ada orang tak mute. Okay, it's Amirul tadi. Okay. Okay, so moving on, and then we talked about the techniques of adding vectors and writing vectors in another vector. Contohnya, I have a vector and I have like r vector, small r vector. So we talked about equality of vectors. So a vector is only equal. Okay, a vector is only equal if they have the same magnitude and same direction. Same direction. So this is equal vector. Okay, but what if they have the same direction, but it's not, the magnitude is not the same? We can equate them together, however, kena ada a constant lah. Macam for example, R ni is half the length of A. So I can write R vector is equal to 1 over 2 A vector. Or I can say A vector is 2R vector because I need 2R to make 1A. Okay, so I can equate them if they have the same direction, but their lengths are not the same. And then we talked about what if the vector is opposite direction, but it is parallel. They are parallel but opposite direction. We can still equate them together. However, we need the negative sign because the direction is different. So I can say A is equal to minus 2R vector because I need 2 R's to make the A. Ini macam lebih besar pula. I need 2 R's to make the A, but I also need the R to flip for the direction to be the same. So this is how the negative sign is there. So equality in vectors, you have to know, you have to understand this part lah, okay? You can equate them if they are in the same direction, even though their lengths are not the same, and they have to be parallel if they are in opposite direction. So this is for equality in vectors. And then we talked about addition of vectors. Okay, new slide. Then we talked about addition of vectors. Okay, addition of vectors, does it have to be the same direction for us to add vectors? Soalan, does it have to be the same direction to add them?
No.
No, they can be different direction. And what is the technique that we learned yesterday to add vectors?
Tail and tip.
Apa?
To tail.
Tip
Tip
to
to
tail.
tail, tip to tail. Ha.
Tadi saya dengar tail and tip kan?
Geometrical.
Tip to tail. So this was our first method. Kita ada a bunch of other methods lagi yang kita belum belajar. So we talked about tip to tail. And if we are adding a bunch of vectors A, B, C, D, kita boleh tukar dia punya order. A, B, C, D. Tapi this would be equal to B, C, whatever. Tak kisah order dia. Okay, so if you are adding vectors, they should be equal, even though the order is not the same. Okay, and then kita buat this example yesterday. Let me just go back to it. And we found out that when we did the tip to tail, even though the order is not the same, the final resultant vector is the same. So you really need to know how to do this, tip to tail ni. Okay, so where am I? Okay, so this, when we add vectors, contohnya A plus B plus C, the final result of that vector is typically called the resultant vector. Ni nama dia. So if you tell me, doctor, the resultant vector is blah, blah, blah. So I know you're talking about something that is addition ataupun subtraction. Memang dia punya total lah basically. The total of the vectors, the net of the vectors. So resultant vector is typically denoted as capital R with the little arrow thingy on top. Always have to have the arrow thingy. If not, you have to bold it, but payahlah, saya takkan tahu pun korang bold ke tak. Tulisan kita semua bukan cantik sangat kan. So just use the arrow. Okay, adalah orang yang cantik. Saya punya je yang buruk. Okay, so please use the arrow so I'm clear on what you're trying to write. Okay, what else? So tip to tail. Okay, so tip to tail method. Let's say we're talking about A, B, C. So I start with A vector. I don't necessarily have to start with A, but in this case, I'm just following the order here. So the tip of A is connected to the tail of the next vector, whichever vector that you want to draw lah. So in this case, I'm drawing B. So the next vector punya tail is connected to the tip. And then C, okay, C is like that contohnya. And then the resultant will always be from where you started drawing to the end point. So this is your resultant. So your resultant starts at the same place that you started A, B, C, D. Sorry, the place that you started drawing your vector lah, the first vector. Start to end. Arrow, take note of the arrow from here to here. So dia nampak ni, dia opposite. So tak boleh sama. Kalau sama dia tak resultant dah lah. Dia jadi benda lain, dia negative R. It's not a resultant, it's a negative resultant. Okay? Okay, so that is our recap. So let's go on to the tail-to-tail drawing. So our next method of drawing, of adding vectors. So for tail-to-tail drawing, you are limited to only 2 vectors. So tail-to-tail drawing ni limited to only 2 vectors. You can't add A, B, C, D, E, F, blah, 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 semua tu kan. Only 2 vectors, because when you add them, you have to connect everything by the tail, and then first kita letak macam ni A, and then we connect B by the tail. Tadi tip to tail, this is tail to tail. Tail of A is connected to tail of B, and then this is the important part. You need to draw something that is parallel. You need to draw a line that is parallel to your A and a line that is parallel to your B. They must be parallel and they must have the same length. Okay, jangan terbabas ke, terkecil ke. It has to be the same length and it has to be parallel. And then you connect these two together, and this is your starting. The tail is your starting, and the end point is where you drew the thingy the line, dashed line. So you go from here to here. So dia punya direction arrow tu macam tu from start to the end. So that's your resultant vector. So in this case, dia tak label capital R tu, dia buat A plus B vector. So I can just write like this. Because I'm lazy, I just use R. Okay, so this is tail to tail drawing. So let's try a different one. Let's see if we have another example of that. Tak ada. Let's make up one. New slide. Okay, so I have design, home, layout, plan. Okay. Korang nanti please remind me if it's 8:40, because saya selalu macam tersemangat cerita then forget that I need to go somewhere. I need to go somewhere 8:40. Okay, so we have another 20 minutes. So let's try. I have a vector A like this. Kenapa ni? What happened? Oh, I have a bunch of chat. Kejap. Doktor memahami. Cantik. Terima kasih. Sekilas itu. Okay. Thank you for answering on the chat. Okay, A. We have vector A, vector B. Contoh. So I want to use the tail to tail method. Kita dah fasih tip to tail, right? Now we want to try tail to tail. So these two, they look similar. So how do I do it? So let's try it. So A vector, I start with my A vector. I'm adding A and B to get my resultant. So this is our aim. Okay, so we want to add them together. So first I draw my A. Kenapa A saya lain? Abaikan yang ni ya. So let's just copy because I can't draw to save my life. Okay, so this is my A. I'm adding my A to B. So I'm getting this B. So tail to tail. Okay, tail to tail. So I need to connect B with the tail of A. Pandai-pandai lah, sambungkan tail dia kan. So when I connect them together, it looks like this. Okay, and then what is the next step that I need to do? I need to draw something that is parallel to A. Okay, first connect the tail. Tu sambung. Okay, second, draw dash line. Okay, what is the criteria of this dash line? It must be parallel and same length as our vectors. So let's do that. I think I'm going to struggle. Kejap, let me just try. Okay, saya sangat tak confident dengan lukisan dia. So okay, this one like this. Okay, so hopefully this is the same length. If it's not, imagine that it is the same length. And then the third step is to label, sorry, not label, draw. Draw your R. Draw your R resultant vector from the tail to the to where the dash line connects. To where the dash line meets. Okay, so let me try. So from where we started, the tail, to here. So this is my R. Okay, so that is how you do tail to tail method. Okay, kenapa penting? Nanti kita akan discover kenapa tail to tail method ni penting. Alright, moving on to the next one, triangle rule. So I believe you've studied this in high school. I think this is modern maths code. So you first you have a triangle. You have a triangle and you know the length of A, length of B, and you are given the angle of B, which is labeled as capital B. This is angle, angle. So angles kat sini is A and B, and the length given here is small a and B. So AB, angle B, angle capital A. You want to find out what is your resultant vector. So here they are using the tip to tail. So this is vector A added with vector B. So resulting is C. C vector is equal to A vector plus B vector by tip to tail method. So A vector connected to the tail of B, and then from where you start to the end, this is your resultant, your C. C is your resultant. Like I said before, you don't have to always label your resultant as R. You can label it something else, but universally kita akan pakai R. Boleh je label benda lain tapi. Okay, so first, okay, so you have A and B and you have B and A. You don't have C, abaikan yang ni dulu. So you need to know what is the angle over here. You need to know what is angle C. So how do you do it? You know that a triangle has 180 degrees total angle inside it. So with this information, this knowledge, you minus with the A angle and the B angle to find out what is C. Okay, you can find out what is the C angle. So now you know what is the C angle. You can put it inside this equation. Okay, so you have A, you have the length A, you have the length B, 2AB, this is length, cosine of angle C. This is from your calculation of this guy. Okay, so from here, you get the magnitude of the resultant vector. You get the magnitude of C, which is the length lah. So this is the magnitude of the resultant vector. What about the direction? The direction. So in this case, we see that the direction is actually the angle of B, which is confusing, right? But I told you before, a vector is defined, the direction of a vector is defined with respect to the x-axis. Even though this guy is labeled as the capital C, sorry, this guy is labeled as the angle C, this is not the angle, not the direction. This is simply the angle inside the triangle. So this is something that you need to take note of if you're using this method. So again, what is the direction of C? Your direction of C vector is always with respect to the positive x-axis. Tak kisahlah ada B ke, ada A ke kat sini. Always try to find the angle over there. Okay. You can use, you already know lah kat sini because it's given. B is given, right? So you already know because this guy is already on the x-axis. So your B angle is actually the direction of your vector. And this equation gives you the length. Okay, so we don't really use the triangle rule, but it's good to know it. Okay. Okay, what about subtraction of vectors? Subtraction of vectors. So as we mentioned before, as I mentioned to you before, if you are, if a vector is in the opposite direction, contohnya A, we have A like this. If I draw it like this, it becomes negative A vector. Okay, sama juga dengan addition ni, is simply flipping the direction. So you have A and B over here, and they want you to solve this. They want you to find the resultant of this guy, which is A minus B. You are given A and B. There's no minus here. So what do? You need to flip B. Okay, you need to flip B to get your minus B. Okay, and then you use the tip to tail method. This is your tip to tail method. So you go with A. This is your A vector, and then you connect with your minus B vector. It's the same thing, except that you have to be mindful that your B is now a negative. So it goes in the opposite direction. Jangan letak benda Allah ni pula. Jangan letak positive B. You have to put in the negative B. So when you put in the negative B, you are basically doing this. A plus minus B. Okay, it's the same thing. But of course, it becomes A minus B. So this is what you're trying to do. So tip to tail method, you add them together, but the B should be flipped because the direction is opposite. I think this is quite straightforward because we already understand the tip to tail. Okay. Do I have questions on this one? Doktor macam mana nak tahu guna method yang mana? Dia akan bagi tahu, they will tell you what method they want you to use, which is why you have to know all the methods. If not, you can choose the one that you're most suitable, you're most comfortable with. I would recommend the last method nanti. Kita belum belajar lagi. Doktor, yang garis putus tu wajib lukis ke? If they ask you to draw the resultant using the tail to tail method, yes. Kalau nak tanya, kalau tak letak arrow kat hujung, salah ke? Yes, salah. Sebab vector always has direction, and the only way to know direction is, oh, okay, you want to put the arrow kat tengah. Janganlah letak kat hujung lah. Okay, jangan letak kat tengah-tengah. Instead of ni. Saya rasa macam Saya tak tahu. Saya kena check if it's still considered a vector if I draw it like this. It still has direction, right? But it's not conventional lah, the way you draw it. Please draw like this, for now. Saya tak tahu lagi betul ke tak yang ni. Okay, what else? Okay. Alright, so we have learned the tip to tail and the tail to tail. I've given you the instruction on how to do the tail to tail. Given over here, tulisan buruk. Korang faham kan? Because everyone is smart here. Okay, moving on. Okay, now we go on to the last technique, which is the vector component. My favorite actually. Let's go on to animation first. Okay, stop sharing. Alamak, saya dah terbuang. Okay. Am I sharing my screen or not? Macam bukan. Excuse me. Okay. Can you guys see this?
Can.
All right. Thank you. I have a bunch. Okay. So here we have an animation vector addition. So let's try it. So tip to tail method, I think. Let's try it. So I have vector A. Nampak tip to tail ke? Okay lah, boleh lah. Vector A and vector B. Kita buat pelik sikit lah. Tak pelik sangat pun yang ni. Pelik tak ini? Boleh lah. Okay, so I have vector A and vector B, and I want to know what is the resultant. Just looking at this, you already know it should go from here to here. Okay, kita dah belajar that much. So I want to find out what is the resultant. What happened? Saya terkena buat balik. Sorry. Let me refresh this. Tak pandai pakai lagi. Okay, 2D. Let's go. Okay, again, trying this again. A vector, B vector. I already did this with another class. Don't know why I'm not okay with this. And then disuruh buat C vector. Fine. I'm using C vector. Want to do it like this. So the resultant should go from here to here, right? So let's see what is the sum. Oh, it's here. Sorry. So the sum is this length and should be that. Okay. So that is the sum. We already know this. This is like easy. Okay. So now I want to talk about the resultant vector here called S. The resultant vector in this case is called S. Okay. It doesn't really matter. So I want to know, how do I know the angle? How do I know the angle? Can anyone tell me? How do I define the angle for vector S? So vector S is going down. How do I define the angle? Anyone wants to try?
From x-axis.
Okay, from x-axis. So my x-axis kat sini, right? My x-axis is over here. So what? So I can just define it over here. So how should I say it? How should I say the angle? Okay, contoh kat sini 50 degrees. 50 degrees So how should I say the angle for my vector ni? Dia dekat bawah. Instead of the typical situation that we have, which was over here, right? Typically our resultant was over here. So now our vector is down here. So how do we mention this about our vector? 310 degrees. So 310 degrees. I told you guys it was 50 over here. So Molly said she's taking it from here to here. Boleh? Correct. So Molly said 310 because she is referring, alah tak boleh lukis. She is referring from here, nampak kat sini, from here to here. From here to here. So because this is 50, so 360 degrees minus 50 is 310. So that is Molly's approach. another way to describe this vector is you can say, yes, you can say minus 50. Betul, Molly. You can say minus 50 because dia dekat bawah of the x-axis. That is also correct. So both are acceptable. So 310 or minus 50 with respect to the x-axis. Kenapa minus? Because all this while we talk about the anti-clockwise punya direction of the angle. But when we are talking over here, we are actually going clockwise. So it's the opposite way of defining the angle. So we have to include the negative sign. But that's okay. Nanti kita akan go over this lagi. That's the angle. So now what about the values? So I have the values here. Can anyone tell me how do I get the value for my S? How do I get the value for my S, the length? Anyone wants to try? Please unmute yourself. No one wants to try. Everyone forgot already how to get it.
Pythagoras.
Pythagoras. Okay, but in Pythagoras only works for triangles, right? This is not a triangle. So there's another way of finding the length. Very straightforward. Ada tak siapa-siapa yang tahu?
Scale.
Scale, yes. Use your ruler and measure it and then convert it to the scale. Betul. Thank you. So use your ruler. This is geometrical method. Remember, geometrical method, you're using your ruler and your protractor. So you can basically measure and then convert it back to the scale that you define. And for the angle, use your protractor. Okay, so you can do that. Now I want to mention about components. This is where we continue with the last technique. Tekan sini. Okay. So when I click on vector S or our resultant vector, I see that it has an angle of minus 69. Sorry, it's not 50. So I was wrong in defining the angle. So it's minus 69. As Molly mentioned, it should have a negative or it should be 360 minus 69, which is berapa? Saya pagi-pagi sebenarnya otak saya tak berfungsi sangat. 291, 291. I'm a night person. Morning, I'm not a morning person. Okay, so 291 degrees or minus 69 as they specify here because it is below the x-axis. It is below the x-axis. X-axis kat sini. Angle dia dekat bawah. So it's a negative. Okay, tekan balik. So now they've given me these two values. So XS, SX, and SY. SX and SY. So SX means the X component of S and SY is the Y component of S. So in this case, it goes, cuba saya nak lukis. Okay, tak apa. Korang tengok saya punya arrow ni dulu So so the component of Y, the Y component of S is negative 13, which means it goes down like this. Okay, tak apa, saya introduce dulu, jangan panik kalau tak faham. Then the X component of S is to the right, which is a positive. Okay, so let's figure out how to determine the X and Y components of S. And we are out of time. So we are going to continue the component method next class. I really have to go. I'm really, really sorry. I have an appointment for my son. So any other question before we wrap up? Before I end class, basically, stop sharing. We will talk more on the components. Any other questions? No questions, no doubts. Everyone's okay? Everyone is happy this morning? Okay, please don't forget to sign in your attendance on Putra Blast. Okay, I'm still breathing. That's good. I hope everyone is breathing. Please don't stop breathing. Okay, doctor. Okay, scared. Okay, okay. Okay, component method ni kita akan sambung. It's quite lengthy, so I have to explain a bit. So that was just an introduction. If you want to explore that animation. I will give you the link dalam Telegram kejap lagi. Okay, so with that, take care everyone. Doktor video semalam nanti doktor akan bagi hari ni ke. Sorry, saya terlupa. Saya tak sempat nak upload lagi. So I will give you the video from yesterday, the video from today, and also the link to the animation so you can play around during the weekend. Okay? So take care. Bye everyone.
Thank you,
Aduh.
Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Doctor.